Now here's the big question. How can a function not touch a point but still have a value there? That's exactly what limits are, and today I'm going to make sure it's very clear for you to understand. So now let's check it out. So now whenever you see a graph like this, and for instance, let's say this particular graph, the x here, the x here is equals to what? 2. My x there is equals to what? 2. Now if this x is equals to 2, now then from this 0, this is the aspect of s, so it's moving. Now look at this very well. Now let me trace it down to this side. If it's going to what? 2, it is then approaching what? 3. So limit is all about what it is approaching and not what it is exactly. So the limit is talking about where is it going to and not where it is exactly. As of when it is going to 2, it is approaching what? 3. So the limit of this particular graph, the limit of the function of this graph is then going to be what? 3. As what? An answer for that. So now, since you get my point, now let's talk about this other graph. Now let's say for instance, this is a graph, and also our x here is going to what? 2. Our x is equals to 2 here. So now, when this x is going to what? 2, like this, from the top. When this s is going to 2, let me say 2 is around this place. Now what it got there was what? It got to what? It was now approaching what? 5. Now, I'm giving an instance just to explain what limit of a function is. Now, this x is what? Equals to 2. So when it's going to 2, then this man here is going to what? 5. Now, let's look at it from the bottom. So from this point, when it's also going to 2 from the bottom part, this man here is now going to what? 2. You understand me? Let's say this one is going to 5 and this one is what? Going to 2. So now from the top, the limit of this function is going to be what? 5, because that is what this is approaching when it is what? When s is what? 2. You understand me? So that is what this is approaching. So now from the bottom, it is what? 2. Now if you look at this, there are two different values. And in limit of function, two different values cannot be in both the left or you say the right. Now let me put it like that. You can either call this the right part and this is also what? The left. So now two different limit cannot occur. So for this, you are going to say that for this question, there is no limit. You understand me? There's no limit because for the right and what? The left, or for the top and the bottom, they are actually what? Different. So there's no limit for that particular question. So now let's talk about this. Now say when there's an O in a graph. Now what's an O? An O is a value that is supposed to be there, but due to one category or one stuff, it's missed out and it was not there. For instance, now let's say this graph here have a O at the point 1 and 4. So let's say this is 1 of this graph and this is what? 4 in the other axis. You know, this is the y axis and this is what? The x. So this is 1 and this is 4. So they are meeting at this point, and at this point they are meeting, there is an O there. Now if there's an O there, what we're actually going to look for here is that when they draw this graph, now this value of x is then equals to 1, not like this ones that are equals to 2. Now when the value is approaching what? This particular one, when the value is going to 1 or when the value is at 1, it is what? Approaching what? This particular place, which is this point. You know, from this point, this graph is what? 1, 4. If I follow what I have here. Now that's a point, that's a coordinate where they are meeting. So now that's 1 and 4. So from this point, since my x is equals to what? 2. So my y is approaching what? 4. So the limit of this particular graph is going to be what? 4. You get what I'm doing? Now, what I just want you to understand is that limit is not what it is. It's what is actually approaching. So let's talk about this particular one. Now, if you look at this, now, if x is equals to 2, now, the value here, it is approaching what? 3 in terms of this graph. It is approaching what? 3. But when you put the value of x inside what you want to solve as 2, you're actually going to get 7 as the actual value. This is the actual value, 7. But 3 is what is approaching. So now, the answer for this is that the limit to this function is what? 3. Why? Because limit is all about what it is approaching and not what the actual value is. It's more like where it is going to. You understand me? So now, this particular graph, it is moving towards 3, but the actual value is 7. So when you are asked to look for the limit is going to be what? 3, because limit is talking about what it is actually what? Approaching. So now, this is a very important key part that you need to note, which are all these I have written out here. Now, first of all, a limit. Now, limit is what the function is what approaching. That's just a clear definition of what limit actually is. Now, secondly, if left and right are equal, then limit exists. Now, in this example, now because of this stuff is unequal with this, that is why there's no limit. So if they are equal, then limit exists. Now, if they are different, then there is no what? Limit, like you see what we did there. So now, even if there is a hole, limit can still what? Exist. Now, even if a number is missing, I say a hole is something that is supposed to be there but not there. So now, even if this particular place is missing, there is still a limit, which is what it is approaching. So we are not talking about the hole or what is the actual value. We're talking about what it's actually approaching. So limit simply means what the function is approaching. So since you now understand this, in the next video, we're going to be talking about how to solve practical questions, exam questions on limit of a function. So follow for more tips and see you in the next series. Now go out to check that out now. Bye.